This is Professor Mascarella, and tonight we are going to talk about building AI, artificial intelligence recommenders using Microsoft Machine Learning Studio. Artificial intelligence is what only humans used to do. The information about the lecture I will give you tonight are published into resources for the class. So the first part is all about CNN, but the second part is going to be recommenders algorithm introduction. This is just what is the recommender algorithm. The second is the information about how Microsoft implemented this algorithm in their Machine Learning Studio offering, and therefore how to tune the parameters for getting better performances. Then I publish some scientific documentation from Cambridge, UK about this algorithm that Microsoft uses. Actually, those are apparently either Microsoft researchers or affiliated with Microsoft. And then I published the concept of collaborative filtering, that is a very popular mathematical technique, and there is more information. I just want to make sure you guys know that every lecture I provides you documentation you can read. I know there are people that are visual, watch the recording and learn. There are people that are kinetic and they need to do the exercise, but there are people who want to read, and this is just the full documentation. In any case, I encourage to read. This is fantastic material, handpicked. Whatever is here, there's nothing redundant. This is a must read. If I feel this is optional, I will write it's optional. But those are must read because are fantastic gems, gift to humankind about the understanding of this topic. So, machine can predict what you want and call it recommenders. AI knows when you feel a need, a desire, a wish before you know. Think about this. The machine knows your desire before you know you have a desire. Knows a wish before you know you have a wish. Isn't that pretty much like stunning? Who uses this mathematics better than anybody else? Amazon. If you go there to buy a book, very likely you buy two of them because they figure out how to recommend something that you very likely buy. What else? When you see advertising or news, all these news are pretty much customized by understanding your behavior. When you use map services, the retail store proposed in the route are typically recommended because of your attitude of what you like, what kind of restaurant, Chinese or Italian, and things like that. The next is the very popular matchmaking websites. How, among millions of candidates in the system, how do you know which candidate you are more likely to want to have a match in a conversation or a coffee? That is recommender mathematics. So can you believe that the soft, intangible thing of why you like somebody can be coded into mathematics? So when people call this is chemistry, it's wrong. Or say there's no chemistry between us. Probably we should say there is no mathematics between us, right? And another example, if you do what I do, I take classes online all the time. One of them, my favorite, is Coursera, but there's EDX, there's LinkedIn. Actually, the university has an agreement with LinkedIn. When you watch a class, then there is plenty of other classes recommended. Another less well-known application is this one. Offer of coupons or promotions like perks. So this is a real application I worked on several years ago. So what is happening is we look at what people purchased. So here is the item you purchased. Here is the customer profile, 40 years old, 1,000 point purchase method. And so this is like a way in which we are going to recommend a service. So this is a house and home coupon and credit card. You know, those credit card with points, loyalty points. In order to keep loyal, you got to make sure people use your points, because if you don't use them, you don't care about staying loyal. So this system has an item data collection, account user ID data collection, and the output is, with your points, I'm going to recommend a free designer consultant. Why? Because this guy bought 10 appliances, 2 bedrooms, 1 piece of furniture. Well, that's probably doing some remodeling, right? So what happens if you are in the middle of remodeling and somebody says, I offer a free interior designer with your points? Very likely the person is going to use it. In the same time, look at the way this was built. So we had category, genre, kitchenware, bedroom, appliance, and we start drawing this, and pretty much appliances, 10 appliances major. So this is the profile of what type of shopping, and this is the profile of the person. So I'm doing this example because it gives you a clear understanding that in order to recommend something, you gotta have 2 sets of data, the items and the user. You might want to understand both, and you want to make as an output a recommendation. So what is the logic behind the recommenders? How can we predict how the particular user will rate all those movies he has not actually seen? So we're dealing about, you have not seen the movie, and the system knows if you're going to like it. Of course, the answer is in the process you already know. It's going to be a machine learning experiment where we load the data, we do feature engineering, and we build the model. Same usual things. But can you see how many different applications we're doing? It's incredible. All right, so the process is the usual. You have step number 1, you need to have clarity of what is the business problem you're trying to solve. The second is get the data, collect, clean them, then understand the features and the algorithm to model, train the model, test the model, and evaluate and improve the model. How? Lately, we have learned this technique called iterative gradient descent technique. You need to plan a recommended experiment. When you want to plan an experiment, you need to have clarity on this. It's a reverse engineering experiment. No matter if the experiment was done by somebody else and you need to do improvements, so you need to understand what somebody else did, or if you need to start from scratch, you still need to look at this process, business, data, features, model, improve, because that is the process. So in this case, when you look at the new experiment, business problem I give to you. The business problem is you are going to build a competitor service to Netflix. And your objective, you are hired, paid $1 million to build a movie recommender. So you have a customer. Now, what do you ask the customer? All right. If somebody says, build a movie recommender, the first thing is, do you have data on the target user? It means, do you know who is Giuseppe Mascarella, age, city, habits, you gotta have data on the target user. The second thing is you gotta have data from a lot of users, like a public database for 10 years. So users that not just your user, but others. The third is, what are the challenges? And the challenge, okay, so let me do this. So on number 2, when you say you have information about the target user, what does it mean? You need to know that regarding a user, his ID, what he has purchased, what has watched, what he clicks on, and the time spent on watching certain movie. All this information are useful. It doesn't mean you have all of them. You might have only the clicks, you might have only the rating, you might have this, but those are like ideal. If you have all of them, you're very lucky. All right. So training data. What type of training data you need from a public database? Typically, you buy them from your competition. And in this case, you need user ID, item ID, in the sense if you're going to go and buy, you don't want to buy everything you can. You want to buy what you really need. In this case, you're going to buy user ID, the item this user is buying, and the rating. So if I gave a 5.0, I want to know which movie and what was the user. So I want these 3 items, and I want this for 10 years from a lot of data. So missing data, trustworthiness of the rating, decision on user or item approach. And this decision on user and item is something you guys don't know yet, but I'm starting to pick your curiosity about that. The next is what algorithm, and we're going to use the Bayes Matchbox. There are plenty, but this is one of the, I would say, well-known. Performance requirement. F1, orient the curve, but in reality, what is typically used here is the square error. Okay. So now let's look at how the algorithm works. The algorithm has 3 entry points. One is called item-based recommendation, and this applies the science of collaborative filtering. And this means that we have data about the item. What does it mean this? If the user doesn't log in, you have no idea who's watching it. And there are plenty of business, including Yelp and TripAdvisor, that people are very reluctant to log in and being identified. And therefore, you have no choice other than have item-based. And therefore, if you're watching this movie, you have under this kind of more like this big picture movie, and you have more completely based on the item. The other one is based on the user, and this is what typically Netflix uses. Because when you start a new subscription, it says, take a minute to personalize your website. It asks you, what do you like? Now, since Netflix figured out that there is a family, and therefore whoever created the account doesn't mean they represent all the viewers that will use the account, they created a system with the avatars for which they incentive different people to log in with different avatars. So if the child log in, there is a profile and collects data about the child. If mom log in, collects data about the mom. If there's dad, collect data about dad. So these are really, really important. And here, actually, you have 2 nice articles that describe this very well. About how Netflix works. about this and how he uses it. So how do you know if your system is working on a user base or into item base? Typically, when he says top 10 for Angela, this is a user base. Just for you, this is a user base. When you have your avatar, this is a user base. Number 3, it is a blend of the two with a new technology called Matrix Factorization, and this technique is no longer collaborative filter. This is called content-based. And in data science, you gotta know these terms because in an interview or in a conversation with a data scientist, you can like, I don't know what is content-based. You gotta know. So approach item-based plus user-based plus leverage social data that capture the sense of the trait of the person, that generates the most accurate but also most complex system. Okay, so how do we sort out these maze? The first thing is to predict what humans want. You need to start to understand the science of traits and characteristics. For example, a person can be a grown-up or a child, and there's a big difference about what a grown-up watches versus a child. But there's also another type of trait you want to look like. There are people that watch Hollywood mainstream movie, and there are people that look at cult movie, the rare and nobody's seen. So to give an example, the Clockwork Orange, that's a little bit black and violent, is for grown up and a cult movie, while Disney's Cinderella is more of a child and Disney is more mainstream. The question is, where are you in this chart? And when you log in, you already have a little bit of information about that. Now, this is the same chart. This is the same chart. And look how this works. A user, a blue dot, rates an item, red dots, positively if the vector are aligned with the item vector. So if blue is the user, red is the dot, and I watch a movie and that is aligned, I start over time to define a cone. This cone is called latent trait space. And the entire mathematics of we're going to look today is just about finding those latent trait space. And at the same time, the latent trait space can help you in the other direction, in the sense that over time you keep watching more mainstream and more kids, you know that this is the direction you will predict. But at the same time, it can work in the opposite direction, that you're going less mainstream, less children, and more grown up and movie, and this is when you become a teenager. So this latent trait works in both directions to predict. Now the question is, what about new user? That is pretty much the important part of the business, because you want to make sure you attract a new user and you sell a lot. So at this point, since I'm a new user, I don't have data. For me, I know nothing about this person. I don't know what he likes, what he has been watching before. And the only thing I can do is create a cone that is based on what's called metadata. And what are the metadata? Profile information. For sure, when I onboard him, he gave me the age and the city. So I can start to do the prediction, thinking like, all right, that person lives in Indianapolis, countryside, Midwestern, is this age, so you start to make prediction based on those metadata, and over time you switch from less metadata to real data. The algorithm we're going to see today has 4 entry. Generally there's 2, but there are 4 because 2 are the user and the item. The other 2 are the metadata of the user and the metadata on the item, because you need to deal with the new user problem. And in terms of item, you can replace the name of the movie with the genre that the person chose when he logged in and became a client. The actors the person likes, when you ask at the profile, the director, the year of production. So now there are people that like old movies, there are people that like new movies. It's as simple as that. So how does the algorithm work? And this is mathematics called Matrix Factorization. So what we're going to do now is we're going to do feature engineering around what is called a tuple: user, item, and rating. Those are the basics. We generally use way more. Click, length, in the sense like, yeah, I watched this movie, but did I really finish it? And did I watch the first 5 minutes or the first 30 minutes before deciding? So there's plenty of more data, but let's keep it simple right now. And let's say that the rating was not only star rating, but was like on Facebook, positive comments, sentiment analysis, or actually look at this, saved movie. If you put this movie to watch, all this have queue them. That's another things that is the interest. A movie rewatched, or how powerful is to have this information about movie rewatched, right? And the scoring is 1 to 5. So let's look at this. This customer has 4 customers: Carmen, Joseph, Leonor, Esmeralda. And those customers have almost all watched those 4 movies. So Carmen's, when he watches Alien, he rates 5, Bugs Life 4, Cars 1, and Dark Knights. While, for example, a very different profile is Leonor, where Aliens is 1, so she's not into sci-fi. Cars 3, she likes kids movie. Dark Knight, she still likes even cult movie. So, see, as you can see, very. Now the question is, look at Joseph. If he has watched Alien rank number 5, gave a 5-star, Bugs Life gave a 4, so he likes both sci-fi, children movie, and Cars. No, Cars is probably a children movie. What is gonna be the score for a cult movie like Dark Knight? How do I make the decision? So I wanna pause and I wanna ask Wendy, what would be your guess?
My guess about the Dark Knight?
Will Joseph like Dark Knight?
Can you repeat it again, Professor? I'm trying to...
Given the data we have here, do you think that Joseph is going to like Dark Knight?
Not so much.
Okay. Let's do the math and figure out.
Yeah.
So, the first approach is called item-based.
Yes.
And the item-based means let's look at a movie that has been similar to him. So Cars is generally ranked the same 1, as generally ranked 3 by other users. So there is probably a possibility that when I look at items, this will also be rated too by people that have the same rating on other movies. How about if I go user-centric? At this point, user-centric, I need to find people that think like him, not movies that look like him. who are people that think like him? Let's look at Joseph. Carmen is a lot like him. Look, 5, 5, or 4, cars, 1 and 2, similar. So can we assume that he will judge this movie in the same way he judged the other? So this is a 1. So item base gave a 3, user base gave a 1. How do we solve this problem? Because a 1 means don't watch it, a 3 means probably watch it. The way we do this is approach number 3, Matrix Factorization. And please, this is teaching. In real world, we're not talking about 4 people and 4 movie. In real world, we're talking about 400 million people and 500 million movies. So we're talking about an amount of data that our brain cannot even imagine. So now, how do we build a better recommender from these data? All right, so Matrix Factorization. It attempts to determine latent feature for its item and user and correlate them to predict the rating. For example, degree of scariness and keenness on the movie. So in this case, we're mixing the list, Esmeralda, Carmen, with the type of traits like keenness and so on. Esmeralda likes scary very much, give us a 5, right? And low on kids because Esmeralda gives to cars 1. So Esmeralda profile is pretty much like a scary kid. And so what I'm gonna do is I'm gonna do this. I'm gonna take the since we have 2 scores, I'm gonna do a weighted average. So I'm gonna say 5 times half because I have 2, so 5 times half plus 1 times half because each there's only 2. If I go here, it will be 1/4. Okay. By applying these derivative latent features, we can predict the rating. The rating for Esmeralda will give the Dark Knight can be calculated by multiplying the scariness and the keenness features of her in the movie and adding the result together. So I'm going to add 5 times 2.5, 1 per half, 0.5, the total is 3. So at this point, remember when we were doing the neural network and we need to transform all the pixel in one number that judges everything? That's the same thing we're doing here. We're using one number that judges everything. Now, Matrix Factorization figures out the latent space. How do they represent the user in the space? How do you represent the movie? The rating for user I or movie J, generally called R for rating of IJ, is the sum for every latent factor, kidsiness, scary, fun, and so on, of user and movie. The weight, adjust the weight. The judge. Item recommendation efficiency of algorithm uses normalized discount cumulative gain. So this is a way in which I judge which one is better. Related item uses the Manhattan L1 SDG and the Euclidean. So we have defined new way to define performance the same way we discussed MSE in the gradient descent. And then this is like every scenario you gotta see what is the best way to judge. And those have been invented to judge this one. So you can create a recommender using regression, classification, clustering, but a common approach is called a filter-based recommender. They use the Matrix Factorization, the one we just talked. Microsoft Machine Learning Studio support Matchbox recommender model. They use exactly those 2 techniques. And by the way, those 2 techniques are the one that Netflix uses. Of course, the math in Netflix has been evolving, but those are the fundamentals of Netflix. In Azure ML, you should use the recommender split mode of the split module to prepare the data for a recommender, as this distributes user item pairs evenly between the training and the test set. So you remember when you split, you can go in chunks, random, and here they have a recommender split, and it's just designed to have in a case of a combined user and item, you don't want to take the risk that I have 95% of user-based data for my combine and 5% of item. So you need to use the recommender split, the balance between the two. It makes completely sense, because otherwise, if you take 95% of data coming from an analysis user base, you're not doing a combination, it's just user base. After splitting the data, you can use train Maxbox recommender module to train the recommender. This is information that you're going to use into the experiment. You have an assignment from home. If you skip this one, as you can see, you're not doing the good job. So I created a slide because I want to make sure you do things right. There's documentation, what you can predict with this Microsoft algorithm. You can predict the rating for a given user or a given item. All right. So it means I watched The Godfather. What's the rating for I'm gonna give it to this movie if I'm in the middle of it? Recommend the item to a given user. What is the item I'm gonna watch next, or what is the things I'm gonna like? Find user related to a given user. You know, when you see Match.com, who are the people that more likely think like you, like the same thing, have the same lifestyle? So that's the algorithm that is Match.com or any dating site is based on. So this is very interesting. A dating site is nothing different than Netflix. Huh? Find item related to a given item. So if I buy a knife, an expensive knife, very likely I might want to buy a knife sharpener, because if I care about an expensive knife, I might care about keeping the knife in good condition. So that's another thing. Use the evaluate recommender module to evaluate recommender performance. You can evaluate the model based on the normalized discount, NDG, or the mean absolute error, and the root mean square error. So now let's go into the experiment of what it looks like. So we're going to do load the data, explore the data, feature engineer, build the model, deploy the model. The process you already know. And here we, for the people who don't remember what is the root mean square error, let me repeat the definition. And the definition is the square root of the average of the square of the difference between true and predicted ratings. This measures how well the model approximates the true expected value of the rating and penalize large error. Mathematically, this is the square root of the difference between the true and predicted rating. So E of theta is the true, E of theta with a little sign is the predicted rating. So you do the difference, the error, and you do this. So this is pretty much using gradient descent on this variable. What's the difference with the mean absolute error? The MAA is the average of the magnitude of difference between true and predicted learning. So this is pretty much theta minus theta with a simple minus theta, no squared, no square root, is just the average of the difference. So this is good measure to perceive accuracy of the system. Means this is the closest to the real world. But if you need information, not just under the real world, you want information on am I taking risk? Am I exposing my company to lose money? At this point, you want the RMSC, that is the closest to the F1s, because it penalizes large errors. Now, if you're scared about losing money, you're investing money, you definitely want to use the RMSC, because losing a lot of money will really be a bad event. So even the first one doesn't tell you as much of as a risk you're taking as using the second one. Okay, so we're going to look at the data source. And so we're going to look at data on movies. So I'm going to type here movie, and I find the movie rating, because we're going to do recommenders. So I need the ratings from history, you know. And then the other thing we have is when we look at the movie rating, visualize. So you right click here. By now you should know, but if I go too fast, you go here, you right click, you go visualize, and then you see the data. Here we have a user ID, movie ID, rating, 10 stars, 5 stars, and so on, and timestamp. All right, now we want to do a recommender for movie. Therefore, for a new movie, or for a new person, we want to recommend a movie. And to do that, we're going to need the movie ID, the rating, and who was the user that gave the rating. Okay? Timestamp is not that necessary, but for now, let's leave it there. There is going to be a moment where we're going to eliminate this, but this is a good data source. What we miss in this data source is we want to predict the name of the movie. Here we have movie ID. So what I'm going to do is I'm going to take the database of the movie titles in English. So for movie ID, I have the title here. So for movie 417, Le Voyage dans la Lune, from 1902. Wow, that's a very old movie. So I'm going to need that. All right. So the first thing we need is to clarify that the ratings, it's not a classifier, it's not category, it's not text, it's an integer. So what I'm going to do here is I'm going to define this as an integer. So to define as an integer, what is the definition of integer? The definition of integer is an information about the data, but it's not the data. The information about the data is called metadata. So what we're going to do is we're going to work on metadata. So if you write metadata, here you get edit metadata. So you go here, and you connect those two, and here you're going to tell that you want to define the ratings not as a text, as a category, but as a pure integer, not a floating number. So I launch a column, I take the rating here, and I click here to say move this from available to selected column. When I go here, I'm looking at begin with all columns or no columns. They say take no column, but include the column rating. So on the column rating only, not on everything else. Everything else stays as whatever it is was defined, and in this case was text. Here, the one selected, what do I choose? Floating, Boolean, date? No, it's an integer. At this point, I need to join the database of the name with the ratings. So to join them, I go here and I write join. So I join from here and from here. Now, when I join two tables, I need to have something in common because otherwise I don't know what to join. So the thing in common between those two is movie ID. So I go here and I say on table number 1, select movie ID. Okay. On table number 2, select movie ID. And by the way, those are the same because if I go here, it's the same, as before. So you can choose by name or by rules, but in both cases, you're doing the same. You're selecting movie ID, and you click here to say confirm. So at this point, out of the table, we have one table. Now, we saw that there was a column that was useless, the timestamp. And to reduce computing powers and make machine learning more precise, we just want to eliminate any garbage. How do we eliminate any garbage? I'm going to go here and select what I need and exclude what I don't need. So select column in a data set here. So I go from the table to here, then I go into launch the column, and here I'm going to select what I need and leave behind what I don't need. So what I need is called the tuple, means user ID. Then I'm going to need the rating, and then I'm going to need the movie ID. So is it clear at this point what is happening? We are selecting the 3 things we need, and we're going to leave behind the timestamp. Now, the next is, if you look at this data, you're going to see, well, even if you don't see, you're going to be worried about the fact that there is always duplicate. So it's good hygiene to eliminate duplicates. So before you start the algorithm, you go to duplicate. And you go here, you connect, and you go here. What you're going to duplicate? You're going to duplicate movies, eliminate movies with multiple movie ID, because at that point it will be unbiased, the weight in which you give to a certain movie, so no duplicate entries. At this point, once I have the data that have been cleaned and prepared, it's time to split them. So I go here and I try to find something that splits the data. So in splitting the data, I have a few choices. I will split the row, recommender, regular, relative. Since this is a recommender, and there is something specialized recommenders, I'm going to use the specialized recommenders. And we know why we do it in the lecture, that the splitting for recommenders is a little bit particular, because otherwise you don't get a very good split. Once you split the data, you're going to send one part to the training the algorithm, the other part is going to go to the score when you test it. So let's go now and train the algorithm with a recommender. So I'm going to go into a recommender. I'm going to try to find train matchbox recommender here. And the same time, if I train, I need to prepare for scoring it. Remember, the difference between training and scoring is that the training is the logic of the algorithm. The scoring, after you've done the logic, is how many times you guess right or wrong. So I get this one here, and you see I can put in all of three. Just for simplicity, I prefer the first one on the left. And then this other part here, so I go, the data are going to be split, and I left wherever the recommended recommend, 0.5, 25, just the default. I trust the default. But I could start tuning, but I do the tuning after the first run works. So I take the 50% of the data, send here, I train, and I send the training data to the scoring. As you can see here, it can only go here. Everything else is in red, and here is trained Matchbox recommended data. At the same time, the other data that I hit from the training system, I'm going to send to the scoring. So the scoring compare with the training data, I get that you're going to like this. With the data from the database, I'm going to see, did I guess right or wrong? Now, this is going to be done for like, I don't know, if you have a 5,000 into your training set 5,000 times, but then you need data like an F1 score, an AUC, or accuracy that put all together. It says compare this with other things and tell me if it is better or worse. So you need to go from just scoring to give me some reports about this, and this is what is called evaluate. Evaluate takes one data point from here and another data point that comes from the source. Here we should get the all the data like the AUC, the accuracy. Okay, as soon as this is being executed, you get the green check mark, green here, green here. So this means, for example, that the joint is already done. You couldn't visualize the joint. For user ID number 2, movie ID, this one has this rating, timestamp. This is it's the same movie ID, 454876. So even if the name is different, they use these two columns. I could have called this this is a joke, and still so the name doesn't count because it's the content that now is synchronized that counts. And now on this move ID, you have the name Life of Pi. So now you have a very nice, rich, complete data set. Okay. So we have the data set, select the column. So should we test if we dumped the things we don't need? Yes. Visualize. You see, we have the true tuple, user ID, move ID, rating. Everything that was garbage is gone. If you want machine learning training algorithm to train well, you better give only what is needed and no duplicate. So now we're going to remove duplicates. What we can see here by right clicking is that we have 15,742 after removing duplicate. If we see before removing duplicate, we're 22,000. There were 6,000 duplicates. So I'm glad we did it, right? So right now, we remove duplicate and we eliminated 7,000 of them. Now it's time to split. So out of, we know there are 15,000 records. Once we split, let's see how many are here. Out of 15,000, there are 11,000 that went here. And let's see how many are here. And there are 4,000 that are here, you see? So 4,000 versus 11,000. So this means that we have 1/4 versus 3/4. So the split here was done of 0.25 are here, 4,000. Actually, which one test? So 0.25, 1/4 are here, and the rest are here. This is the split recommended. From here, I go and train the algorithm. And the algorithm is the one we studied with the cone. If you remember the latent trait, the cone, you can here change the number of traits. The higher is the trait, the more cone and more specific you get. Number of training batches is how many times you can run the precision. So the more you increase this, the more you get precision, the more computing power you use, and the more sometimes you might get no gain. So from here, let's see, visualize. You have the training and you have the prediction. We go to the score, the matchbox, and the scoring, if we look at the score here, visualize the scoring. So we have a user, items, and at this point, we just scored that for this user, we predicted those items. And when we see that this is the output, and we go into evaluation, we should find the statistics. And here as a statistic is using the NDCG. I was expecting area under the curve, to tell you the truth. And what you, when you don't remember, is what I told you before. Remember, you just go and Google it. Of course, you gotta give context. Yes, it's here. How to evaluate the best recommended system is a topic of debate. Let's us see how we can use the NDCG. So NDCG is a measure of ranking quality. In information retrieval, such measure assess the document retrieval algorithm. And justification for use this, the underlying assumption, and here you have an article. Just read it. So sometimes you don't need to remember everything. You just need to remember that Google will help you, okay? And here we got an NCG of 0.93 that is quite high. Remember, those index have been normalized to be most of the time between 0 and 1. It's just a common practice in data science. And every time you find something close to 0.9, you did a good job. In this case, we did a good job.